The HCP prescribes methicillin 3 grams IV in 150 mLs of 0.9% normal saline to be infused over 1 hour for a client with pneumonia. Now, the drip factor is 10 drops per ml. What is the drips per minute for this client? So anytime you see GTT, you're thinking drips. And we're always recording the answer as a whole number. Because remember, you can't give half of a drop here. So first off, focus on what you're calculating for. So in this problem, you are calculating GTTs per minute, basically drops per minute. So when calculating GTT per minute, your answer should always be recorded as a whole number. So this question obviously is asking for drops per minute, so let's set up the equation. So remember, TV makes you deaf over time. So TV is the total volume, DF is the drip factors there, and time is 60 minutes. Remember, 60 minutes and not 1 hour. 1 hour is for a pump. So we're going to set it all up here. So we have 150 mLs for total volume, 10 is the GTT, and then over 60 for 60 minutes. Now, when we add up the numbers, we have 1,500 over 60, right? Then we do simple division, and it's 25. So the correct answer is 25 drips or drops per minute. Now, question number 2, the healthcare provider prescribes IV erythromycin, which is an antibiotic, 200 milligrams in 250 mLs of LR, that lactated ringers. It doesn't really matter what they're giving it for. So, okay, for food poisoning. Now, the drip factor is 15. What is the drips per minute for this client? So as you do, let's set up the formula here. TV makes it deaf over time. Then we're just simply plugging in our numbers, right? So 250 for total volume, 15 for the drips, and then over 60. Always remember, it's 60 minutes. So we're going to multiply the top row and divide. So when we multiply the top row, we get 3750 divided by 60. Now, our grand total is 62.5, but we have to round up because remember, we can't give half of a drop, right? So the answer here is 63 drips or drops per minute. The thing here is the time, right? Now for question 3, the HCP prescribes methoxin 1 gram 50 mLs in normal saline to be infused over 45 minutes. Okay, the key term there is 45 minutes. And this client is scheduled for surgery. The drip factor is 20 GTTs per ml. So again, what are the drips per minute? So once again, we're setting up the formula. So TV makes you deaf over time. But the big thing here is the time, right? Instead of 60 minutes, it's 45 minutes. So simply plug in our numbers here. So 50 is the total volume, 20 is the drip factors, over 45. So multiply the top row, we get 1,000 over 45, and so we divide. Now we have 22.2. But again, we can't give 0.2 of a drop, so we round down. So the correct answer is 22 drips per minute. Question number 4, the healthcare provider prescribes 1,200 mLs of normal saline to infuse over 6 hours. Okay, so that is a big key term. 6 hours is not 60 minutes, right? What is the drips per minute for the client? Okay, so set up your formula as usual. TV makes you deaf over time, right? So let's plug in the numbers. We know the total volume, that's 1,200. The drips are easy because that's 15, but listen close right here. The time is 6 hours. So we do 60 minutes times the 6 because for 6 hours, right? So now we can multiply across both top and bottom. So we get the numbers 18,000 over 360. Then we simply divide and we get 50, and that's a round number, so the answer is 15 drips per minute. Now moving on to question 5, the healthcare provider prescribes normal saline with 20 microequivalents of KCl, that potassium, right? To infuse at 100 mLs per hour for a client with low potassium, that hypokalemia. Now the drip factor is 10, so what is the drips per minute for this client? All right, so let's set up our equation here. So total volume times dF over time. So TV makes you def over time, right? Now let's plug in our numbers. Our total volume is 100 mLs times 10 drips per minute over 60. Remember, it's always 1 hour is 60 minutes. So multiply across and then divide. So when we multiply across, we have 1,000 over 60 and simply divide. So we get the number 16.6, and obviously we're going to round up because we can't give a portion of a drop. So the answer here is 17 drips per minute. Now, moving on to question 6. The healthcare provider prescribes 1,000 mLs of normal saline to infuse over 12 hours. Okay, that's the key number. Over 12 hours because it's not 60 minutes, right? This is for a client who's dehydrated. So the drip factor is 15. So what is the drips per minute for this client? So once again, we're setting up our formula. TV makes you def over time. So for total volume, it's 1,000 mLs. Drip factor is 15 and 60 minutes times 12, since there are 12 hours here. So please don't forget that step. Okay, now we're multiplying both top and bottom across. So we get 15,000 over 720. Then we do simple division, and we get 20.8. So we must round up because we can't give a portion of a drop, right? So the correct answer is 21 drops per minute. Now, moving on to question 7. The healthcare provider prescribes ciprofloxacin 400 milligrams in 200 mLs of D5W. Guys, nothing matters, only the 200 mLs. To infuse over 1 hour. For a client diagnosed with, who cares, right? Streptococcus pneumonia. All right. So focus on the numbers here. So the drip factor is 20. So what are the drops per minute for this client? So as you can see, questions are going to try to confuse you. So it's your job to pick out the key numbers. All right, so now let's set up our formula. TV makes you def over time. So the total volume here is not 400 milligrams. Total volume is 200 mLs of that D5W. Now the DF, the drips, are 20. And it's always over 60 minutes unless the question tells you otherwise. So now let's multiply across, and we get 4,000 over 60. Our grand total here is 66.6. So obviously we have to round up because we can't give half of a drop here. So our correct answer is 67 drips per minute. All right, now for question 8. The HCP prescribes 63 mLs of a medication to infuse over 40 minutes. And the drip factor is 15. So how many drips will the client receive here? So as usual, we're setting up our formula. TV makes you def over time. So for total volume, that is 63 mLs, right? And then for the drips, that is 15. Now, it's not 1 hour anymore for time. It's 40 minutes because the question told you it was 40 minutes, right? Okay, now let's multiply across. 63 times 15 is 945. Over 40, using simple division, we're getting 23.6. And then we have to round up because we can't give a portion of a drop. So the correct answer here is 24 drops per minute. Now for question 9, the provider prescribes 500 mLs of D5 IV over 12 hours. Okay, so this question is telling you it's over 12 hours, right? Now, this is for a client who's hypoglycemic. Now, the drips are 60, so how many drips will this client receive? So let's set up our equation. TV makes you def over time. So our total volume here is 500. The drips are 60. And here's where the part gets tricky. The question just told you it's not 60 minutes anymore. It's 12 hours. So we use the 60 minutes times the 12 there, and we simply multiply across. So once we do the multiplication, we have 30,000 over 720. And we get the number 41.6. So obviously we have to round up. So our correct answer here is 42 drips per minute. All right, last one here is question 10 for drip factors. So the healthcare provider prescribes 2 liters of normal saline IV to infuse over 16 hours for a client receiving chemotherapy. Now, the drip factor is 10 drips per ml. So, what is the drips per minute for this client? All right, so this question is giving you liters and not milliliters. So, first, you have to convert those 2 liters to mLs, right? So, as you know, 1 liter is 1,000 mLs. It's a normal bag of saline, right? 1 liter of saline. So 2 liters would obviously be 2,000 mLs. Now you have to make this conversion before you start plugging in your numbers. All right, so as usual, we're setting up the equation. So total volume, TV makes you deaf over time, right? So now we plug in that 2,000 mLs times 10 over 60 minutes, and the question said 16 hours, right? So 16 hours times 60. Okay, now that it's all set up, simply multiply across. So we get 20,000 over 960. And then we do simple division. 20.8, and we have to round up because we can't give a portion of a drop. So we have 21 drips per minute. All right, let's get into IV infusion flow rates using a pump here. So question 11. The healthcare provider prescribes 150 mLs of 0.9% normal saline to infuse over 2 hours. What is the infusion rate for this client in mLs per hour? And we're going to be recording the answer using a whole number. So let's break it down. First, focus on what you're calculating for. So we're calculating for mLs per hour, not drops per minute here. So to set up the equation, remember, TV makes you deaf over time. The trick here is we're not using drop factors or drip factors here. So it's just TV over time. So total volume, 150 mLs, over the time, 2 hours. You divide 150 by 2, and we get 75. So the correct answer is 75 mLs per hour. All right, now for question 12. The healthcare provider prescribes 1,000 milliliters of D5 half NS, that half normal saline, to infuse intravenously over 8 hours for a client who's hypovolemic, basically low on volume. How many mLs per hour should the client receive? And remember, we're recording to the next whole number here. So for the rationale, let's break it down. What are you calculating for? We're calculating for mLs per hour, not drops or drips. So to set up the equation, remember, TV makes you deaf over time, but we're not using drips. So just total volume over the time here. So we have 1,000 mLs over 8 hours. So simply divide 1,000 by 8, and we get 125. So the correct answer is 125 mLs per hour. 32. So our correct answer is, all right, question 13. The healthcare provider prescribes 1,000 mLs of normal saline to infuse intravenously over 24 hours. How many mLs per hour should be administered? So what are we calculating for? We're calculating for mLs per hour. So remember the rounding rules. All right, so let's set this up. We're just calculating total volume over time. So 1,000 mLs divided by 24 hours. So 1,000 divided by 24 is 41.6. But remember the rounding rules. Anything over that 5, we're rounding up to 42. So 41.6 gets rounded up to 42. So our correct answer is 42 mLs per hour. Let's break this down. Now, question 14, the HCP prescribes 2 liters of normal saline to infuse over 18 hours. What is the mLs per hour here? So remember to record your answer rounding the nearest whole number. So let's break this down. What is the problem and what are we calculating for? Well, we're calculating for mLs per hour. So remember the rounding rules here. So 1,000 mLs over 1 liter times 2 liters over 18 hours. So let's do our multiplication here. 1,000 times 2 is 2,000. And 1 times 18 is 18, right? So simply do 2,000 divided by 18, and that gives us our lucky numbers here. 111.1. So it's going to be 111 mLs per hour. Now for question 15, the healthcare provider prescribes 1,000 milliliters of normal saline to infuse intravenously for a client with fluid volume deficit due to metabolic alkalosis, that acid-base imbalance. The prescription is to infuse normal saline over 10 hours. So how many mLs per hour will the client receive? So record your answer as a whole number. So let's break it down here. We're taking that total volume divided by the time. So this is really simple. 1,000 mLs over 10 hours, right? So 1,000 divided by 10, we have 100. 100 mLs per hour is our answer. Now for question 16 here, the HCP prescribes 500 mLs of a solution. It really doesn't matter the solution. 500 mLs to a client with hypernatremia, that high sodium, who cannot tolerate PO fluid intake. So the prescription is to infuse 500 mLs over 4 hours here. So how many mLs per hour will this client receive? Record your answer as a whole number. So very simple, just total volume over time. So our total volume is 500 mLs over 4 hours because that's what the prescription says. So the correct answer here is 500 divided by 4. We have 125 mLs per hour. The correct answer, 125 mLs per hour. Now, moving on to question 17, the healthcare provider prescribes 400 mLs of lactated ringers, the LR, to infuse intravenously over 4 hours for a post-surgical client. What is the mLs per hour for this client? And remember to make sure, record your answer as a whole number. So what are we calculating for? We're calculating for mLs per hour, right? So we're just taking the total volume over the time here. So mLs per hour, we have 400 mLs, our total volume, over the time, 4 hours. So 400 divided by 4 is 100. So 100 mLs per hour is our answer. All right, now question 18. The healthcare provider prescribes 1 liter of lactated ringers to infuse over 8 hours after surgery. What is the mLs per hour for this client? And make sure for mLs per hour, we're recording as a whole number. So very simple again here. Total volume over time. So total volume is the mLs. So we have 1,000 mLs, which is 1 liter, right? And we're multiplying 1 liter over 8 hours here. So just multiply across. 1,000 times 1, which is 1,000. And 1 times 8 is just 8. So 1,000 over 8, basically 1,000 divided by 8, is 125. So the correct answer here is 125 mLs per hour. Now, question 19, the healthcare provider prescribes IV dopamine, 5 micrograms per kilogram per minute for a client who weighs 63 kilos. Now, the medication is a stinker here. It's only stocked as 400 milligrams in a 250 ml bag. Crud. So what is the mLs per hour for this client? And recording your answer, rounding to the nearest 10th place. All right, so before this gets super confusing, let's just line up our targets and shoot them down properly. So first off, what are we calculating for? We're calculating for mLs per hour. So setting up the equation of dimensional analysis here, we're trying to determine mLs per hour. So write mLs per hour here on the left. Now let's set it all up. So 250 mLs over 400 milligrams here, because the 250 ml bag is the total volume. And underneath is the 400 milligrams. And we multiply that by 1 milligram over 1,000 micrograms, because 1 milligram equals 1,000 micrograms. Now on top, we have 5 micrograms per kilogram, because that is what the question is asking for, right? Now the client weighs 63 kilos, and we're over 1 minute. And then the last part of it here is 60 minutes in an hour. Now, as you can see, normal dimensional analysis, we're just trying to block each other out. So, as you can see, we have the milligram on bottom and a milligram on top, and a microgram on top and a microgram on the bottom. We're just trying to cross each other out. So, in the end result, we're getting milliliters per hour. Okay, so now we're multiplying across the top and the bottom here. So on the top, 250 times 1 times 5 times 63 times 60 gets us a big, huge number of 4,725,000. And we do the same thing on the bottom to get the grand total of 400,000. So we divide those huge big numbers here, and we get a milliliter per hour of 11.81. Now remember, we have to round to the nearest tenth. So the correct answer here is 11.8 milliliters per hour here. All right, question 20. The healthcare provider prescribes IV dopamine 20 micrograms per kilogram per minute for a client who weighs 75 kilos. Now, the medication is stocked as 100 milligrams in a 50 ml bag. What is the mLs per hour for this client? And record your answer rounding to the nearest tenth place. All right, so first things first, what are we calculating for? We're calculating for mLs per hour. So we put mLs per hour on the left side here, right? Then we line up our targets and always make sure that an ml goes on top and we have an HR for hours on the bottom here. So let's line it up. Starting with 50 mLs on top over 100 milligrams times 1 milligram over 1,000 micrograms, because 1 milligram is 1,000 micrograms. Now, times 20 micrograms over 1 kilogram here. And 75 kilos, because that's what the client weighs, over 1 minute. And the very last one is 60 minutes in an hour here. So as you can see, minutes on top and minutes on bottom. So we cross each other out, and we're trying to get to that ml per hour. So now we have everything lined up, so let's multiply across. 50 times 1 times 20 times 75 times 60 gets us a big, huge lottery number of 4,320,000, right? And we do the same thing on the bottom. 100 times 1,000 times all the ones gets us 100 grand. So we have that big number divided by 100,000, and we get 43.2. So the correct answer here is 43.2 mLs per hour.